Hello, this lesson is an introduction to HTMD. In particular, we're going to do an overview to see what's coming in this course. My name again is Carson Meredith from the School of Chemical and Biomolecular Engineering at Georgia Tech. The outcomes of this lesson are going to do an overview of the purpose of high-throughput materials development, and we're going to preview what's coming in these course modules. So the first question, and I think the most important, is what is HTMD and why should I care? Well, first thing to understand is that materials are key to solving many problems of industry and society, and these include problems in medicine, automotive, aerospace, and energy sectors, as well as many others. The challenge in developing new materials is that materials are complex. So what do I mean by complex? Well, in a materials development effort, you first of all have many compositions, sometimes thousands or even millions to consider, and processing conditions like temperature, flow rates, exposure to light, and so on. This combination of processing and composition can lead to huge numbers of samples that you need to look at to develop a material. And in combination with this, you also have material structure, the nanostructure, the microstructure, and the properties of the material that you're interested in. All of these are essentially interrelated in a very complex way that makes the materials design challenge difficult to approach. So HTMD, or high-throughput materials development, is a set of tools designed to accelerate development through three steps. The first is intelligent planning and selection of experiments. The second is exploring large numbers of compositions and processing conditions in a relatively short amount of time. And third, integration of the large data sets that you generate with advanced computational and learning techniques. So I'd like to spend a few minutes overviewing the course. This course is divided into 5 modules intended to give you a very good working knowledge of HTMD. The first module is an introduction. So we're going to talk about the purpose of HTMD, its position in the Materials Genome Initiative, and we're going to talk about each step: library creation, high-throughput screening, and materials properties testing. Each of the steps will give a brief overview of each one. From there, we're going to go in and do a detailed overview of library preparation. So libraries are really the heart of high-throughput materials development. And simply put, a library is a sample that contains large numbers of other samples. So you might have hundreds, thousands, or even 10,000 materials compositions on one relatively small wafer or in an array of vials or wells. And what you see pictured here are liquid handling robots preparing mixtures of samples on microtiter plates, for example. In Module 3, we're going to talk about what you do with those libraries. Usually the first thing you want to do is make sure you know what the compositions are at each position in your library and what the structures are. So we're going to talk about high-throughput ways to characterize those compositions and structures on your libraries. In Module 4, we're going to talk about high-throughput property measurements. In particular, you're always interested in some type of functional materials property that lends itself to an application. And there have been many ways developed over the past 15, 20 years to do high-throughput property screens, and we're going to talk about many of those. Finally, Module 5 aims to put all of this information together. So we're going to take what you've learned in the first 4 modules and talk about how those 4 steps are applied to developing materials in energy, carbon capture, metal alloys, and maybe some others. And these will essentially be case histories of real materials development efforts. So that finishes up this brief overview. So what are we going to do next? We're going to talk about how HTMD fits into the Materials Genome Initiative. And my co-instructor, Rick New, will be introducing a guest, David McDowell, who will take you through that introduction. Thank you.